Hi, I'll go over lab 4 of ECE 286, which is about AC power. So for experiment 1, you have a fairly simple series RC circuit where you're varying the frequency. So you're supplying 5 volt with a 100 nanofarad capacitor in series with a 1K resistor. In this demonstration, I'm switching that 1K to a 3K, so my results will vary from your results. And the objective is to measure the voltage drop at these 3 frequencies and find the relative phase difference between the power supply and the voltage of the resistor and the voltage of the capacitor and the resistor. So what I will do is first I'll connect my circuit. Okay, so here's my circuit. So this top portion is my circuit, this is the resistor. That's obviously not. Okay, this is my capacitor, the ceramic capacitor, and then that's my resistor. My channel 1 is measuring the voltage drop across the capacitor. Channel 2 is measuring the voltage drop across the resistor. And then the green is my input, which is connected to the yellow cable coming from the M2K, and then I've grounded my circuit. So I will open up Scopy. Cool, go and click connect. A moment. Okay, cool. So now I'm going to go to the signal generator, and then I need to supply, let's see, 5 volts. And then I'm going to pick 10K as my frequency. So let me scroll all the way up to that and increase to 10K. Cool. So now I'm going to go ahead and click run and then switch over to my oscilloscope. And then let's make this a tiny bit bigger. Okay, and then let me click single. A lot of waveforms. Let me extend that out. And then increase. Nope. Increase this to that single. Okay, let me just double check this system. Yeah, cool. Okay, so now just measure the voltage drop. So you have the voltage drops because of the measure feature that I've enabled. So if you click the box, box next to the text that says measure, you can enable that. And then you want to measure the voltage drop, phase between the power supply and the voltage of the resistors and the capacitor and the resistor. So this is the waveforms of the capacitor and resistor. So already you can easily do the phase by clicking on cursor, clicking on the settings, the 2 parallel lines, and go into track and then dragging them to the peaks and then whatever the time difference is. So let's just say this is a rough estimate. So it's about 26 microseconds, 26 microseconds times 2 pi divided by the period will give you the phase shift between the resistor and capacitor, but we need to also do the power supply and the resistor. And the only way to do that using the resistors and capacitors voltage drops is doing a math function and adding both of these 2 signals up. So I'm going to click add and then go down here, click T1 and then to plus and then T0 plus T1, add channel, and then go ahead and click single again so I can gather that data. Okay, now let's see. Now let's actually record the phase difference between the power supply and I believe it said resistor. Got to double check. Resistor. So resistor is channel 2, so my purple waveform. So let me just get rid of this setting. Yeah. Cool. So now my power supply is all the way up there, and then I'll just go to my peak of that. So it's pretty close. So I got a roughly 5 microseconds. So to calculate the phase shift, of course, it's 2 pi times that delta t divided by the period. And that will give you your phase difference. So now you have a RL circuit. It's essentially the same thing, but the only difference is you're evaluating at different frequencies. On this side, on the RC, you have lower frequencies because capacitors have a higher impedance at lower frequencies, but have low impedance at high frequencies. So that's why we tested at low frequencies. But for our Ls, or specifically inductors, they have a higher impedance at higher frequencies and lower at low frequencies. So we didn't even test the low frequencies. So you'll go ahead and do that. So I'm not going to go through experiment 2 because it's the same procedures as experiment 1. And then for experiment 3, it's pretty similar to experiments 1 and 2, but you're having an additional branch and you have more components. So you have 3 different frequencies, 100, 5K, and 25. So a pretty wide range of low, medium, and high. They're frequencies that are covered. And then you want to measure the voltage drop of the 2 resistors in series, and the power supply and the capacitor branch and the resistors in series. So this resistor and these resistors voltage drops and the phase shift between these. And pardon me. No, I had it. No. Yeah, so this whole branch compared to this, that's the second bullet point. And then the first bullet point is, yeah, so essentially these 2 bullet points are the same. So just measure the voltage drop across this and compare it to the voltage drop across a parallel branch. So I'll do it pretty quickly. So let me rewire my circuit. Okay, cool. Yeah, so I've replaced these components with different ones. So I believe, yeah, so no, dude, this is the exact same circuit. I lied. Okay, cool. So these are all the 100 ohm resistors. That's the 1K. So here's my 100 ohm that's in series with the voltage supply. That's in parallel with that capacitor branch with 100 ohms. And then that load branch where there's 2 resistors in series with one another, which is the 1K and the 100 ohms. You know what? I'll just swap this 1K with something else. So this is going to be 3K. So at least it'll be changed. Coolio. Okay, so now that's changed. I'll just go to my Scopy and then get some data points, you know? So I will switch my signal generation from generator from 10K to 5K, please. There we go. And then now I'll just open up my oscilloscope. Go ahead and get rid of this because I don't need this. So go ahead and click single, and there you go. So now you have your max voltage. Channel 1 is measuring that resistor in series to the voltage supply. And then channel 2 is measuring this whole like branch right here. From my interpretation of this manual, for these 2 bullet points, they're the same, unless if your TA specifies which specific resistor in this branch. Just confirm with your TA what they expect. But yeah, you can easily measure the voltage drop by the measure feature being enabled. And then if you enable the cursor, you can measure the phase difference by going to the peak and then using simple math by relating the delta time to the actual phase shift. Okay, good luck.